Okay, we'll start. So you wanna intro or do you want me to intro? I can intro. Okay, cool. Thank you guys. Welcome to come to this workshop session. Today we're going to talk about Ethereum. So just to rewind. So yeah, last time we talked about mostly the history of blockchain stuff, which included, the philosophical ideologies that drove the invention of blockchain to the invention of Bitcoin, which are crypto anarchism and cypherpunks, which is just like cryptographers think that this is the only way out. Government cannot take control of cryptography, and we need to build a world that's secured only by sort of cryptography and these constructs, rather than trusting the government, trusting the big banks, the insurance companies, and that kind of ideology. Pretty extreme, to be honest. And then we talk about hashing. Hashing is basically you take whatever data and then you run it through this function, and it spits out a unique sort of fixed length string. And if you change anything in the original file, the string, the resultant string would change drastically, which means that by saving this string, you can later make sure that the file is not tampered with. And then we talked about hash chaining, which is the idea that sort of involved into blockchain, which is you have these blocks of data, and then you keep the hash of one block into the content of the next block, so that rather than checking the hash of all these blocks and making sure that each block is not modified, you just have to check the one at the end. As long as that one's not modified, everything else is not modified. So that's the whole concept of like sort of fundamental of blockchain. Then we talk a bit about Bitcoin. We'll dive a bit deeper in the next slide about Bitcoin, the construction, and the consensus, the security guarantees. This is sort of the review. So in Bitcoin, you have these blocks of data, and we're calling them blocks here. They're just really just like pieces of data that includes sort of money transfer from one person to another. So here you see that in this block there's one such transfer/transaction. Alice is sending Bob 10 Bitcoin, and this also implies some sort of current state of how much money everyone has. Suppose that everyone start with nothing, and I transfer $10 into your account, and then I transfer another 10 Bitcoin to your account, right? Now you have 20 Bitcoin. So by looking at historical money transfer into your account, you essentially get sort of a state of how much money you have in that moment. So this is a block. And blocks are created over time, about 10 minutes per block for Bitcoin. So you have 10 minutes, those are the transfer that happen in that 10 minutes. And then you go to the next 10 minutes, there's three transactions. Transaction is a proper term here. Bob to Alice, Bob to Alice, Alice to Bob. And then at the end of those three transactions, we have this implicit state of Alice has 10 Bitcoin, Bob has 40 Bitcoin, which is differs from the last 10 minutes. And then you have the next block, right? So this is created over time. And each block, as we said, represents how much Bitcoin everyone has at that moment. And as we said, from the concept of hash chaining, the information here is immutable. They cannot be changed once you sort of have that block. Once you told everyone, okay, here's what happened. You cannot then go back to the history and be like, oh, they didn't actually transfer 10 Bitcoin, they transferred 5 Bitcoin. That doesn't work, because if you do that, people can tell very easily, because that would modify all the data after that. Yes?
What do you mean by going back and changing?
So suppose that, at time 1, I made Alice sent Bob 10 Bitcoin, and then now I'm at time 3, right? And Alice has 14 Bitcoin, Bob has 36 Bitcoin. And Alice say, okay, I want to have more money. So, let me go back and say that, oh wait, I want to have more money, so let me go back and say that I didn't transfer Bob 10 Bitcoin, I only transferred 5 Bitcoin. So now I have 5 more. But by modifying that data, you're changing the hash. First, you're changing the hash of this block. So information here is different. And because this hash is stored in the time 2 block, so this block is also now changed, which propagates to the 3rd block. Now this block is also changed. And people who are looking at the blockchain, they have an original copy of this block. The hash says 1, 2, 3, 4, some random string. But now you're saying that no. It's actually not 1, 2, 3, 4. It's actually the version where I send less money. So the new hash is 5, 6, 7, 8. And people can say 5, 6, 7, 8 obviously is not 1, 2, 3, 4. So this is incorrect, and you have modified the history of the blockchain. Yes.
Okay, I can't remember whether we covered this last week, but what if we have like multiple transactions? What if they're like race conditions? Like how do you?
What do you mean race conditions?
Like if let's say Bob wants to transfer like 8 to Alice, and then Bob wants to transfer 8 to someone else, and like he doesn't have he only has like 8.
Right. So it's a sequential execution, right? So whoever that creates this block, someone who decides, people can arbitrarily decide to order this, but they just need to make sure that the first to create the block and then everyone else agree on it. So essentially, you can think about it sequentially, even though realistically they're sending these transactions almost simultaneously. But for any given sort of block proposer, miners to create a block, they need to say, okay, now you transfer 8 Bitcoin. Do you have enough money to make the next transfer? If you don't, then that transfer is not going to happen.
Okay. So it's still like.
So is the point of the block sequencing basically to make sure there's accountability so that people can figure out whether or not they should trust this particular coin?
So accountability. So essentially, it's like executing a program, right? If you have a number 4, and then like 4 stands for someone's balance, it never go negative. So you can do 4 minus 2, 4 minus 1. But then if you try to do 4 minus 3, that wouldn't work. So the 4 minus 3 would just get rejected. So that would never happen. So it's essentially the internal logic of Bitcoin would enforce that your balance never go below 0. And if you try to go below 0, that's not going to work.
So you were talking though about like people being able to tell if you manipulated it. Like, what is the actual like implication of that? Like, how does that like do anything? People knowing you did that.
So the whole idea of digital money, as we said last time, is that essentially there's 2 things. One, you need to make sure that everyone's money is safe. So if I have $10, I have $10. If I come back in 10 minutes, it's still $10. So it can't go arbitrarily to $15 or $5, right? So because you're enforcing these invariants, essentially like, you can't make money out of thin air, you can't make money, go negative. These invariants essentially help you sort of get to that outcome where everyone's money is safe and each transfer is legit, right? It's like I can't say I have $10 and I just arbitrarily transfer $20 to him. That's not going to work. Right? So all of that is to say that we guarantee everyone's money is their money and they can make a transfer properly. Does that make sense?
Yeah.
Okay. So lastly, we have consensus. Obviously, we're just looking at one blockchain. It seems like this can be on just someone's computer. And if there's only one person watching, they can just say, okay, let me just give myself infinite money, right? Like, why not? So the consensus idea is that because digital money is like, I can't just create a money for myself. That's just plain money, monopoly money. I need to be able to buy something with this money. So everyone else needs to agree that this money has value. So in that case, then everyone else is sort of, they have stake in this game in the sense that they want to make sure this account balance and all these transfers are correct. So you have sort of a group of people making this system work. And so for Bitcoin, they use essentially majority voting, and where each vote is sort of solving a cryptographic puzzle, also called proof of work. So essentially, you can't sort of do voting fraud. It's like you have illegal immigrants go vote at a presidential campaign, right? You need to make sure that behind every vote, there's people dedicating their processing power. Essentially, they're contributing their resource to maintain the integrity of this system. And obviously, this participation, why do people want to participate in this system? One is to be able to use this concept of digital money. And second is they're rewarded with Bitcoin. So they actually sort of get paid to play this game. And the more people who participate in Bitcoin, the more secure it is. Because the fact that this is the majority voting system. So if you convince 50% of the people that your fraudulent transaction, you give yourself made up money, as long as you convince 50% of people, then you can give yourself infinite money. But if the network is large enough, like there's like 2 million people using Bitcoin, it's really difficult to convince 1 million people to to agree to give yourself some money, right? It's like why would I want someone else to get richer, right? It's like I can't even convince more people to come to this session. How can I convince 1 million people? Yes.
So what if, like, for example, you like hack or like penetrate a blockchain and you give yourself like insane amounts of money?
Right.
Wouldn't the market or like the perception around it crash because the blockchain has been in a sense violated?
So
The purpose of your stealing is like anyways like negligent.
got you. So let's go back to the situation where we have 1 million people in the network, right? You can sort of create your own version of Bitcoin, and you can say that now I have $1 million. But the thing is, like, the other people are not going to agree with you. They're just going to say that you're wrong, and they're just going to ignore you, and they're going to maintain their state of correct blockchain, how much money everyone has.
What does it actually look like to like vote on the content? Is that just like you saying to everyone, this is how much I have, or what does it actually look like?
So essentially, it's like someone is going to say that, okay, here is a new block, everyone's transactions, and then after these transactions, everyone has how much money, and then you just step in and sort of rerun the program and see, like, is this right? And if you don't think that's right, you're just going to ignore that. And because it's sort of a system of like a gossiping system, right? It's like if everyone believes it's real. So if whoever you talk to are just going to reject your idea, then you're not going to get everyone to believe it, right? So it's like if I advertise this workshop and every person I talk to, they're like, nope, I'm not talking to you, right? How can I get more than 5 people to come? Impossible. So essentially there's a check there.
And do people look at it themselves, or do they have like things to like automate it?
Oh, it's all computerized.
Okay.
So it's a computer, checking, is this block legit, right? 2 things. One is, are the transactions legit? Second is your proof of work, the puzzle solved correctly. Yeah. Okay, no questions. Moving on. That was great.
Okay, so thanks for explaining Bitcoin. So Bitcoin sounds very cool as a concept, and like it seems very useful from hearing what Intel said. But the thing with Bitcoin is like it's a very good like medium of exchange and a store of value, but you really can't do anything beyond that. So this is why we in a sense have Ethereum. And like what people were doing when they were like looking at Bitcoin was like, oh, it's very slow. You can't have a lot of like there's not a lot of like practicality and scalability with Bitcoin. Mainly because it's super slow, it uses proof of work, takes 10 minutes to complete 1 block. So people were creating basically their own versions of Bitcoin, as Intel kind of mentioned earlier. So people had like these Bitcoin Max, Litecoin, and even like Dogecoin is a version because people were unhappy with Bitcoin, so they just created their own version of a separate coin. But the thing with this is like it dilutes the establishment of Bitcoin. And like in one sense, it lowers the value, it reduces the community around it, and which is basically all what Bitcoin depends upon, right? So what Ethereum wanted to do is like, I mean, there's a quote from Vitalik, the guy who created Ethereum when he was 14.
Something.
In a sense,
Child genius.
yeah, he was a child genius. So he basically wanted to create a Bitcoin which you can basically program upon. Instead of creating all these new coins just because you want to implement something slightly different is like very inefficient. So why not make a blockchain where you can program upon and you can like do cool stuff like, I don't know, hold auctions, have like voting mechanisms, and do like trades between different accounts more easily and like automate those trades. So this all gave rise to Ethereum. We'll come to the difference later. And so with Ethereum and in the spirit of our club, you can build cool shit on Ethereum, but you can't on Bitcoin.
Yeah, it's almost like, imagine every time you need to use a program on the computer, you need to like build that stuff from ground up from like sand, right? But now you don't have to because you just have a computer that just can run all kinds of programs, can do all kinds of stuff that you want to do. So you only need to worry about code, and rather than digging into hardware, smelting sand into silicon, right? You don't have to worry about that anymore. And just one more point, we talked about community is important, because Bitcoin security guarantee, which is the whole concept of digital money, because we need more people to believe it, right? If you have limited people believing it, then sort of the value of it decreases. So if you have people who are sort of believing the general value of digital currency, but instead you divide that group into 10 groups, which one believes Bitcoin version 1, Bitcoin version 2, Bitcoin version 3, then sort of the security and the value of each of those cryptocurrencies is like 10 times less.
Yeah.
So we want like one thing that preserves value and does blockchain stuff.
That's pretty much okay. Yeah, so just like an overview of like what's to come and what makes Ethereum, like how Ethereum makes blockchain useful. I'm kind of just throwing terms around here, we'll come to them later. But with Ethereum, you can make new tokens, do decentralized finance, have DAOs, which are decentralized autonomous organizations. You guys might have heard of Franklin DAO in the news recently. And you can have NFTs. You can't have NFTs on Bitcoin. And you can have gaming and metaverse. So just like a bunch of stuff which is to come when we go in the depths of Ethereum. But yeah, let's see how Ethereum works now.
So to understand Ethereum, I wanted to break it down into sort of, think about the simplest computer we can think about is a TI-84 calculator. Like I went to high school here in the US, and TI-84 is something everyone sort of are taught to use. So I hope a good percentage of you guys have used this before. So what is a TI-84? TI-84 can compute numbers using operators like add, subtract, multiply, divide. It doesn't have to do it can do a lot more, right? But let's just stay at that. Actually, add, subtract is good enough for this example. And then they can store variables and use them in the future. So in TI-84, you can store numbers into A, B, C, D. And for this example, we'll just assume that we have A, B, C, D, 4 variables. You can store number into them, and at the beginning they're all set to 1 by default. And lastly, in TI-84, you can read variables and use them in computation. So if A and B are both set to 1, then A plus B, the calculator will say it's 2. Crazy. So now, at time 1, let's suppose that we just have a public TI-84 like right here, and it's free for public to use. Alice comes in and she's like, okay, let me type down, I want the calculator to compute B equals A plus C. So compute the result of A plus C and store it into B. And Alice leaves. At time 2, Bob comes in and says, okay, cool, let me set D to 5, and then let A be the sum of D plus C. So if we look at sort of what is going on under the hood, right? At the beginning, we talked about how the 4 variables are all set to 1. So we have 1, 1, 1, 1. And once Alice sort of executes her computation, it becomes 1, 2, 1, 1. And after Bob sort of computes his formula, it becomes 6, 2, 1, 5. So you already see that sort of if you look at a single calculator, but let the horizontal axis be the time scale, you can create sort of these snapshots in time where in this snapshot, Alice uses the calculator to compute B equals A plus C, and the outcome is 1, 2, 1, 1. And then the next snapshot is Bob comes in and computed his calculation, and then at the end you have 6, 2, 1, 5. So I don't know if you guys see the parallel with the Bitcoin example that we talked about, but essentially these are the blocks that construct that makes up the Ethereum blockchain. The only thing that's missing is that you would hash sort of the content of B equals A plus C and the 1, 2, 1, 1, hash that and put it into the next block. Or I guess I did it backwards. So hash this first one and then put it into the second one, so that you still have that hash chaining effect, so that things are immutable. You can't change the history of. Obviously, sometimes or most likely, or 100% of the times, this is not just one transaction or one computation that they're doing. It's like B equals A plus C and something else and something else and something else. And sort of the end result, the ABCD would just be sort of you sequentially do these computations and what is stored in the computer, in the calculator at the end. Yeah, and like one more thing is that you can consider everything that each person computes as a program, because what is a program? It is just like math but on steroids. So we already have this concept of blockchain calculator. Then it's super easy to go from there to blockchain computer. So one thing we're still missing for the blockchain calculator is that now we're only talking about one calculator and no one's really watching it. So technically I can just go in and change all the computation result, and even so like I can bring a faulty calculator and say 1 plus 1 equals 3, right? No one's gonna know. Now, as we always do with blockchain, we have a group of people monitoring it. Like we're seeing that, oh, is 1 plus 1 equals 2? If that's 2, then checks out. If it's anything else, that's wrong, right? So we're going from calculator then to computers, right? So instead of computing things, instead of calculating, simple formulas, equations, programs, and then do it sort of over time, you're just looking at your computer. But the difference between this computer and your computer is that it's not just you who's sort of using the computer and then you just hope the computer does what it's supposed to do. So you have like millions of people, or I guess not millions, thousands, hundreds of thousands of people who's watching that the computer is computing every step correctly, right? If I click this button, it's going to take me to the web page. Is that correct? Right.
426,000.
Yeah, it's like hundreds of thousands of people. And also importantly that computer stores data. So you also guarantee not only the computation, that click a button and it takes you to the right page, but if you write things down in the notebook, right, you can make sure that unless someone actively try to change it on your computer, no hackers can remotely sort of hack into your computer and change what data that you store, right? You have an important essay that you've written, right? You don't want it to just disappear. You want to make sure that if you wrote it, it's there. So that's sort of the concept of a blockchain computer. And in the Ethereum, this is called the Ethereum virtual machine, which is not a physical computer. It's this imaginary computer. But what is a computer? It's something that helps you compute and that runs programs. So this virtual thing, you can ask it to compute and you can ask it to run programs. So this is Ethereum virtual machine, that's what we call it. It can take requests for anyone to use it. Any of us can install the proper software and interact with this computer. And I'll hand it to Vikram.
Any differences?
Wait, actually, questions.
Another question?
Yeah, wait, so how does the virtual machine look like? Is it like just a network of machines or like?
So the abstraction is it's just a virtual machine that you can just interact with, right? But what it is, it's so it's a network of machines, and it's like one machine actually does the job, actually does the work. It's like doing the 1 plus 1 equals 2, and then the remaining hundreds of thousands of machines just like look at what he computed and be like, is that right? And everyone sort of agrees on it.
Okay.
And it's also like a 50% majority. As long as half of the the people watching it think it's right, then it's right.
And where is like all this stored? Like,
So it's
a lot of data, right?
exactly.
Code down, so
they're actually all stored on each of these participants.
it's divided into.
No, every single computer in this network stores the entire thing. Right.
Like you can download the whole of Ethereum on your laptop if you want.
How big is it? Is
It's
it like
a few terabytes.
Yeah.
Actually pretty small.
That's kind of small, yeah.
Yeah, it's only a few terabytes. And there's also difference, right? It's like, I don't want to have a very beefy computer so that I can do this. I can participate in this, network of computers and do the calculations. Maybe I just want to watch from a distance, and I just want someone to tell me that the outcome the result is correct. So there's a few different tiers of nodes, as we call it, where the full archival nodes, they have all of the data and they can verify every single step from the very first transaction of Ethereum. Whereas most nodes, the next step down is called full nodes. So they have like a set amount of history. And then there's also, other sort of nodes where they have even less history. So they have not verified everything. They just sort of kind of believe that people, the past 1 year is correct. Then I'll go from there. I'll verify everything forward.
If you become a part of the virtual machine by downloading it, but then undownload it, what do they do with like your portion of it?
So if you are you become a node in this virtual machine, right? You're almost essentially like as a person, like, so Vikram is gonna tell Kyle that, Jesus is king. Sorry, I just can't thought of anything. Right, like he's gonna, spread the gospel here, right? I can step in and Vikram can tell me Jesus is king, and then I tell Kyle Jesus is king, right? But then if I leave, right, you can just tell him right away. So it doesn't actually matter. Like my presence is not vital, but because now we have like 2 people versus 3 people, right? Like, you tend to believe
There's
if there's more people, right? And what if like 1 million people like telling this is true, right? You probably believe it. But if, each individual person starts leaving, then you're like, oh, maybe it's not true. So that is sort of the whole idea about like, we want more people to participate.
Yeah, so I have a question regarding like, I know like some protocols that have like lots of accounts and those data for their balances and whatever state like stored on like contract.
Mhm.
But I'm just wondering because it feels like there's a lot of data to store. So on the block itself, do they store like the hash of that thing or like the entire thing? Because I feel like Bitcoin is like you basically have that unspent balance and it's easier to like just to track it. But for Ethereum, like the data is like much faster compared to.
Yeah, I think unspent balance is also like not trivial to track because it has a lot of like your wallet needs to do a lot of the work in terms of aggregating all that. But for Ethereum, you're right that we in each smart contract has sort of states, and in the whole Ethereum network we have states. So as we said, we have a few different tiers of nodes, right? The full archival nodes literally has everything everyone has ever talked about on Ethereum. Like has all that data. That's why it's so big. But for most nodes, they just have the block itself, where the block itself is just the hash, what's it called? Merkle tree root of these data. So a block itself is actually really small. It's like, I would say it's less like kilobytes probably. Right. But then it's because it actually compress everything, all those data. It doesn't store it. It just need to verify that those data are there and correct. Right. It's like
in Bitcoin hash is only 256.
yeah. I mean it's not just one hash. It's like
I mean it's multiple hashes, but like so like you get like one hash is only 256 characters. So that's not like you're storing like hundreds of billions of.
Right. I mean, I guess one analogy would be that your professor, we're all in like classes, and professors don't usually grade the homework. The TAs do, right? Technically, how does the professor know students have done their homework? Professor should actually look at the students, do their homework, and see the filled out homework sheet. Then they know the student actually have the homework done. But what do professors do? Professors just ask the TAs, are they done? They're done, right? It's sort of like that. Except it's not sort of the trust of the TAs that's at play here. It's a whole cryptography system.
Like you can like extend that example, like explain consensus as a whole.
Sure, maybe.
Like
Add that to our analogy bank.
sure. So example like okay, let's say Shiv submitted a homework for like I don't know, let's say it's 7,000, and we have a group of 10 TAs, and I'm a malicious TA because I'm Shiv's friend. So even though he did his homework wrong, I gave him full marks. But then the other 9 TAs see, oh, Shiv didn't do his homework correct. So we need to so they figure out my version of truth is actually a lie. And then they come on the consensus that Shiv didn't do his homework.
And they can either ignore Vikram or they can kill Vikram.
Yeah.
So you can kill Vikram.
They can kill Vikram because this person is not trustworthy.
Wait.
Now you're gonna hear from a very good word.
Whoa.
Okay, okay, a lot of consensus, but why is blockchain useful? Okay, let's look at this through an example.
So I guess the transition would be that, so we talked about executing program accurately, and that's very important. And on blockchain, that we're trying to explain that there are, it's important to be able to accurately execute a program, and that can be very useful. And this is an example.
Okay, imagine we're in a different universe. There's only two characters in here. There's Winnie the Pooh and there's Tigger. In this case, I'm Pooh and Intel's Tigger. And so imagine there's nothing between us. I want the pot of honey, and Intel has the pot of honey. I have cash for him, and he's gonna give me that cash instead. So what if? So this is gonna be a Mexican standoff like situation, because if I give him the cash and he gives the pot of money, I just take both, and now he's down. Like, it's a loss-win situation. And in the real world, I mean the ideal outcome would be that I give him the pot of honey, and I give him the cash and he gives me the pot of honey, and everyone's happy. But sometimes that doesn't happen because, say, I don't like, what if there's like no trust between the both of us? Like, it's probably because as you said, I'm not trustworthy, so I'll just steal the whole thing. So what do we do in the real world to prevent this? We have banks. Banks are the middlemen. If you want to transact, I don't know, if I want to transact with Shiv doesn't trust me. So I want to give Shiv a loan of $1 million. So I put it in the bank, and the bank gives it to Shiv and then collects the money from him. And the bank handles all of the hassle of that for me. So let's say we want to remove the bank from this equation. Let's come back to the pot of honey and the cash. Let's say there's a revolving door between Intel and me. Cool. So right now, neither of us can access. So I put my cash on here. You don't put yours right now. So right now, and then you put that. Okay. So now it's basically logged in escrow. And now the revolving door recognizes, oh, both sides of the party have fulfilled their side of the obligation. And the revolving door then moves
Automatically.
and it gives me the cash.
Oh no, the revolving door. But it's supposed to work.
Yeah, here it is. So the revolving door works. I get the pot of honey and he gets the cash. And we did this without any bank. We had no middlemen. We just relied on
some magical chairs that does its job.
And the revolving door. So this is what like blockchain in a sense was designed to do. It's basically more like programmable blockchain, or Ethereum was designed to do. It's designed to like take away the middlemen of the world. You can extend this example to like voting, like you can remove governments, like insurance providers, banks, and like just you can have tons of applications like auctions, for example. Like, you don't need a Sotheby's anymore. You don't need any auction houses in this universe of Ethereum anymore. So basically, all of this is done through a smart contract. A smart contract is just a fancy word for code which resides on the blockchain. And instead of residing as like I don't know, a Java file on your computer, it resides as on a specific address on the Ethereum blockchain.
And remember the analogy of Ethereum being a virtual machine that everyone can access? It's like you can upload a file on that virtual machine that you can sort of use later. And once they're on there, they're on there.
Yeah, and also one of the most important thing about a smart contract, it's a both pro and con. Is like once it's on the chain, it's on the chain. Like, you can't change it at all. For example, let's say if there's a smart contract which says that the person in the receiving part of the account gets $1 million. What if the person goes on and then changes it to take like $10 million instead? But like, no one checks if he has made the change or not. So that's gonna like mess things up for the entirety. That's why once you put your code on the chain, it's on the chain. You can't change it at all. That's why they're immutable. And I mean, the applications, as I said earlier, they go to like holding auctions, like a ton of like financial stuff.
And also for pen, right? Like, I don't know if you guys dig into the history of the UC Holmes
Township.
You see townhouse, the protest, but the whole reason behind that is that Penn was supposed to pay those people like a $10 million or something, but then Penn didn't actually end up paying that, right? Suppose that was on a smart contract and it's like, as long as they move and then Penn will automatically transfer the money, right? We wouldn't have this whole protest thing and everyone would be happy. Right? So exactly, it's like this kind of, can't trust the authority, can't trust Penn, stuff like that. Yeah. Oh, sorry, one more thing, but it's also bad, right? It's also bad that the code is immutable because as all the CS students, or if you program, you will know that there's our code, there are bugs in the code. Like there's almost always there's a bug in your code. And what do software companies do? They're just like, okay, we'll just try to make the code better. And if we find a bug, we'll fix it, right? That's not the case on blockchain. If you have a bug, you are screwed, right? That's this whole thing about like, millions of dollars, tens of millions, hundreds of $1 million getting stolen on blockchain. It's because the smart contracts are buggy. And once you put money into it, you can't change the buggy contract. So people can just find a way to take the money out. And there's nothing you can do.
Does it like cost something to make a contract? Like what kind of like resources do they have to put in to make it? Or
Yeah,
we'll come on that kind of.
we'll cover it, but yes, it's not free.
Yeah. Okay. So it's exactly just coming to that. So let's come back to the calculator example. So in this case, everyone just like for example, like someone not part of the class just comes in and starts using the calculator. There's just one calculator, like it's not for everyone to use. You gotta give something up to use it. And in this case, to use the Ethereum virtual machine, you give up the currency called Ether. So that's the bounty, or like the basically the currency you pay to get the authority to use a computer for every computation you want to make. So why does this bounty exist? Firstly, it offers security. Let's say there's an exam going on and everyone uses that calculator. So Alice is like kind of done with her exam. She's like super confident that she's gonna get 100. So she wants to like mess up the curve. So she comes up to the calculator and like enters like, I don't know, like a million like computations on it. And the calculator just hangs. So all of the students are now they're done because they can't use the calculator anymore. So how do we prevent Alice from doing this? We just ask her to pay a bounty or like a sum of money every time she wants to use a calculator. So by doing this, you can't overload the system. And also you remember the example of when they're like other people just standing around seeing like if the computation's done on the calculator, right? So, I mean, like what's there, you're just standing there. You got to pay them some money. So the money that Alice uses to use a calculator is also paid to them. It's like distributed to them. So in this sense, you can also understand the word decentralized. Like when we use the bank as a middleman, all the money goes basically to the shareholders of the bank. Like Shiv and I don't get the money. Intel and I don't get the money. Although we're the ones who's using the service and keeping the banks like running. So in Ethereum or like any blockchain for that matter, the people who keep the blockchain running are the ones who get the money back also. So this is why the concept of a decentralized system became very popular. And
I just had a quick question on how you guys see the legislation factor into this. So let's just say that using a smart contract, as you said, if I want to give out money to whoever wants it as a loan, and then the smart contract would mandate those repayments back to whoever gave the capital, correct? So now what if I renege on those payments, or what if I'm delinquent? So whom does the onus fall on essentially? Because when the bank is there, you can point a finger and say, oh, where's my money? Like they look after it. But now without the bank, how do you blame code? What does the code do?
I have a great answer for that. This is so when a bank loans your money, right? Like you can just take that money and run, right? And you can sort of a bank. So you're broke. You go to bank. You be like, give me $100, and bank says, okay, pay me 105 back in like a year. So the bank doesn't really know what's going on with financial. They know about your financial situation, but like you can just take that $100 and run, or you can spend it all, right? And then you have $0 in your account balance. So how crypto works, because the whole concept is that you literally do not know who you're in business with, and you literally sort of have no control over them. So how smart contract actually works is that they literally ask you to have $100 in your account. And once you dip below $100, they sort of, what's the word? Like margin call,
Liquidation.
they liquidate your loan. So you always need to have sort of more than, in fact, more than the money you loan, which makes no sense. So it's like to borrow $100, you need $105 in your account, and always $105. Once it dips below 105, liquidate it instantly. So the bank never loses money.
It's like a bank wouldn't like like a normal bank wouldn't approve you for a $100 loan if you didn't have $105 already.
So it's collateralization, and in crypto, most of the cases it's over collateralized. So you need to have something of more than the value that you're loaning out to make that loan. Does that make sense?
Yeah, makes sense. So, sorry, so like, somewhere I heard like the concept like code is law, so like if you have like a smart contract and it doesn't function as you expected it, like that's still like the fun, like even if you didn't intend it to do something, if it does something, then like blah, blah, blah. So like if you found like a exploit in like a smart contract bank, for instance, and then you got like a shit ton of money, like would that be illegal to exploit that? Because like obviously with a traditional bank, if there's an exploit, then that's basically like stealing from the bank. But like if code is law and like the bank doesn't function as intended, could you like still be held liable?
Yes. Is it okay to profit off people's stupidity is the question you're asking.
Yes.
It depends. And the law is, so again, in the law, it depends, right? You cannot hack a company, that is illegal, but you can be a hedge fund and make money off people's stupidity. So for smart contracts, I believe it is illegal to hack a smart contract because it's still, I think it follows some existing law that, up to interpretation. Like I'm with you. I think, people who deploy stupid contracts should get hacked and, they shouldn't get their money back.
I mean, they do also.
Sometimes.
I mean, there's like what 2 billion, 20 billion in losses.
Again, like right now, like even though blockchain is sort of, the Wild West, but it's not really the Wild West, right? Like the government knows who you are. So it's like, yeah.
What if you're in like Ukraine?
Yeah. If you're in Ukraine, right? Like the same argument can be made a lot. It's like you kill someone, you go to Ukraine, you're also fine. So I guess law has its limitations. It's all the same, right? Like just think about like, computer hacking, the Web2 stuff. It's all the same. Obviously, it's sometimes, it's like the enforcement of the law might be presented differently when you talk about Web3 stuff.
By hacking, do you mean exploiting as well? Because I think that might be like distinct, like just like abiding by the rules that are there, but making a shit ton of money. Like, is that also wrong?
I think it's wrong.
It depends on the case.
Or like I believe the law says it's wrong.
Okay.
Yeah, because like so far all the exploits, right? It's literally people's stupidity, right? It's like, something could be really obvious. Smart contract usually, you can store money in smart contracts, and then as owner you can access money in smart contract, right? But sometimes you can. There's a few smart contract. Literally, it's like anyone can tell the smart contract, be like, I'm the owner now, and smart contract be like, yes, and then give you all the money. Right? Like that is the most stupid thing ever. But is that as an exploit, as a hack? Yes, it would be considered illegal.
There was a homework we did for SIS 7000 when one person sold 150 million because of that issue.
Right.
Like if you just input like some random like obscene number in the smart contract, it'll just it's just like make you the owner instead. So
you gotta be smart,
yeah, you gotta be smart for smart.
And Vikram is gonna plug this SIS 700 class here.
7,000.
7,000.
Yeah, you guys should, if it's offered. I don't know if it's offered next time, but it's offered right now, and like it's all. Wait, I put up a homework in the end of the slides. There's one homework from the class. If you want to like just try your hands on like coding, you can mint your own NFT.
Yeah, the course is called Web3 Security, but it sort of gives you an intro to how to program on blockchain using Ethereum virtual machine, and it also talks about sort of the best practices and how can code be exploited and how to avoid them. And I think it's an excellent class. So if it's offered in the future, I would highly recommend taking it if you're interested in blockchain programming. Like if you do blockchain programming, like you literally cannot screw up, right? It's like regular programming, you just, a bug, you fix it, right? But here it's like a bug, okay, $2 million lost, right? It's like got company fired instantly. Okay.
Switch it off, it's up, can't take it down. Okay. Changing topics again, I guess, but I mean,
Oh, sorry, could you talk a little more about the last bullet points on the last side, like
Oh,
the
like-
more bounty, less time part?
oh, okay. So basically, if Alice comes up with a calculator for like $100 to give to the calculator, and there's Bob with only $50, Alice will skip the line. And
Yes, that's right.
and then make her, oh,
So in the Ethereum world, these bounties to use the calculator or like price to use the calculator is called
Gas.
gas. And then, so essentially they're, okay, I don't want to make it too complicated. Essentially, you pay more, you get better service.
Is the payment like equally distributed among the validators?
I believe.
It's not equally distributed. There are a lot of very technical details, but the validators get some cut of it, is what I can
They
say.
get some kind of it. So where does the rest go?
There's actually right now, some of the ETH just disappears.
What?
Yes,
Wait.
like some of the ETH just like literally just like goes to
Burn.
trash.
Right, that burn, it's constantly burned.
Yeah, it's
And it's burned. So every time you pay to use the calculator, you sort of delete some of the money in the total currency supply, which is interesting. And that was not initially implemented. There was a time where before that time, there is a fixed supply of Ethereum, actually an increasing supply of Ethereum because of there's just money made out of thin air to reward people participating in the network. But since that's implemented, there's also a force where that's destroying the total supply.
Which force is like greater? Is more being destroyed than created? Or
Before it's more, so up till the merge, more created and more being destroyed. To the merge, I believe
It's more burned.
it's more burned.
Because the thing is that you can't mine anymore. Right now it's rewarded by the entire network.
Yeah.
So like the more validated there are, the less reward there is. So there's constant reward, but burning is when more people uses it, the burning will be like, there's gonna be more burning. So right now it's actually in deflationary like trend.
Yeah,
for Ethereum.
I personally did not know that because I did some research on other EVM chains, but not Ethereum itself. But thanks.
Wait, is there like an Ethereum like central bank or something that like determines how much Ethereum is like burned versus like,
basically.
is it just like Vitalik
So-
or whatever?
It's not Ethereum Foundation. They don't get to decide
I
it,
mean,
but it's proposal. So it's very, again, it's voting. Essentially, it's like people agree with it, we go with it. And so the company or the organization behind sort of developing this whole thing is Ethereum Foundation, who their whole goal is try to make this thing work, try to make sure more people use it. So when they propose something, there's usually a very good reason they want to do it, and most of their proposals are like very rigorous, well researched, well designed. So in a way they get to say what they want, but it gets passed by the community.
So wait, so how usually do you have a example of where one thing that was voted on the entire network and then passed, like an example of that? There's like, do all ETH holders get to vote, or like how?
No, I think the developer community gets to vote.
So developer community actually gets to vote instead of like all ETH holders.
So I mean, here's a few things, right? Like first, the EVM proposals are decided with the foundation and the developer community. It's like an open process, but it's not a smart contract. It's more an open process. It's not like 50% vote. Okay.
Yeah.
Because how can you enforce like code changes, right? It's like, what if I say that I want Ethereum to be like $10,000? That's not just gonna happen. Like I want this change to be implemented. No one's gonna someone's to do it, right? So actually, so Ethereum Foundation usually they come out with an updated version of Ethereum, and then they're like, okay, let us all just upgrade to this new system, and then sort of everyone in the Ethereum network are like, yes, I agree, because if I don't agree with you, the rest of the people are going to agree with you, and I'm not going to be making money. So I might as well agree. So it's actually the node operators upgrade to the new system.
And that's kind of voting to the new system.
That's kind of voting, yes. So they're voting with their node operators. Yes.
Got it.
Okay, yeah, we're at time. Sorry.
what's like.
Yeah.
Yeah, coming back here, everyone heard a lot about the merge. what was up with that? I'm trying to make this a bit faster because it's almost 10. So let's get to it a bit quicker. Why this happened? Proof of Ethereum earlier before the merge was like around like what was it, September 14th? Yeah, I think it was like last month or something. They used to use proof of work. Should we just do a quick review of proof of work? Because I feel like there are new faces here.
Sure. Yeah.
Okay. Do you want to use the problem piece set theory?
Sure. Yeah.
Okay. So proof of work. Remember the people that are standing around like looking at the calculator. So the process of agreeing upon what Alice did is right or wrong is called consensus, and there are two consensus algorithms. Majorly, this proof of work, which Ethereum used to use and Bitcoin still uses, and then this proof of stake. So basically, what proof of work does is, in a sense, all the validators in the network, it's basically like, imagine all of them are like students, and just to prove that they have put some effort into checking it, they have to like solve a P set. And this is
Okay, so
the explanation.
okay, cool. So this chart layout reminds me of like a congress, right? Where at each desk you have like buttons like yay or nay, right? But if I were here to say that, okay, we want to like destroy the whatever monument in the US and then let people vote on it. You guys, because there are empty seats, you can just like press your vote, and then you go to the next seat and press the vote, and you go to the next seat, press the vote. So like in essence, one person get to sort of vote multiple times. So that's not what we want. We actually want one person to just have one vote. But let's say that this system is really bad. I cannot control turning off it cannot control turning off the buttons. So how would I do? Let's say that at every sort of station, every button, there is a scanner, and then you have to put a completed P set into it, and it verifies if that P set has been like done before, or has been like scanned or received before. So you all need to do your P set and then submit that P set for you to vote. Obviously, you can say like I want to put in more work. Let me do 2 P sets. Let me do 2 votes. Right? That also works. So in the Ethereum context, that is you running your computer to compute some cryptographic puzzle. And then the more cryptographic puzzle you solve, you get to vote more times. So you could say that, okay, is that the right way to decide who gets a vote? It turns out it's a pretty good way, because if you're dedicating your computer, you're dedicating your electricity to do it, you probably are, you want the system to work. And if you intentionally attack the system, then people lose faith in Ethereum, then all the work that you put in goes to nothing. So everyone in the community are somewhat incentivized to keep it running correctly and not vote maliciously against it. Does that make sense? So that is the first way, which is proof of work. And what is proof of stake?
Proof of stake you explain on next slide.
Okay, cool. But the problem with proof of work is that it uses a lot of electricity, because why would we want to do P sets, right? That's a literally waste of time. Right? So we don't want to do P sets. And in the reality, that uses electricity. And in fact, 99.95 of the electricity in this whole operation is used by this useless task. So that is why people say like blockchain is bad, blockchain is not green, blockchain damages the environment. But lo and behold, we found a better way.
Yeah. Also, it's supposed to be more secure. Proof of stake. Go back. There's 2 more things to mention. Scaling. So as we mentioned, like every time you have to solve a piece, it takes a lot of time, right? In Bitcoin, it takes 10 minutes to propose a new block, but that's just like very inefficient if you want to like have a faster network. And yeah, if you want to have faster transactions, you need to cut that time down. So proof of stake cuts that down. And also, with the problem with Bitcoin is like, or like any mining is like, there's like farms, like you might have heard the term mining farms. And correct me if I'm wrong, there's like 2 mining farms which control around 50% of the total network. So if those 2 mining farms decide, okay, now we want to mess the network up, they have the power to mess the network up entirely. So they can basically change the versions of truth, as Intel mentioned, like
Give themselves some,
Yeah.
give them money.
Imagine if I have control over the 2 mining farms, and then I can say, oh, even though Shiv did his homework wrong, I'll just claim it's correct because I have more power than the other peasant miners. Wait, next slide. Okay, proof of stake. This is what Ethereum transitioned to, and proof of work is basically doing resets. We waste a lot of resources, but we don't want to do that anymore. So what Ethereum has started to do now, to become a validator, to become one of those persons standing to look over the validator, you have to pay 32 Ethereum, like 32 ETH, which is around 50 grand in USD. So just to like become a person standing there, you have to pay 50 grand. But why would you become one? Because as I told you, remember when Alice pays something, you also get some out of it. So it's basically creating a longer term revenue stream for you. And as Ethereum grows, as more people use it, you start getting like more money for your work of validating if Alice did her work right. Why is proof of work, proof of stake more secure? I mean, proof of work, as Intel described, was very secure in the way they do a piece at every time and like everything. But what makes proof of stake secure is basically probability, which makes it more secure. So what Ethereum does is it chooses a committee of 128 validators. This is out of 426K validators out of there. So already your probability of being chosen among the 128 is 128 over 426K. And only one of them out of the 128 people chosen is chosen as the block proposer. So imagine I'm a malicious validator. I want to like propose a fake, a messed up block. So what all do I need to do that? There are basically 2 things. One, I need to have a shit ton of money. 2, I need to be like the luckiest person alive. So firstly, you need to pay 32, like you need to pay 50 grand to become a validator. Then you need to be insanely lucky to be selected as one of the 128. And then you need to be super, super lucky to be selected as a block proposer. Then, because you need to have 2/3 majority to to assure that the block I'm proposing is right, you need to have 2/3 majority, which is like 85 seats out of the 128. So yeah, basically imagine this is Congress. I need 85 votes to say my block is the truth one. So I need 85 into 32 ETH, which is like $136 million. This is like if there's like 100% luck rate and you have $136 million lying around. So imagine if you want to increase the probability of you being first selected as a block proposer, and then increasing the probability of having the 85 seats, it's going to be like, I don't know, billions and trillions of dollars to make that happen. So just because of math, it shows that proof of stake is firstly very secure, and it like you just notice like no one needs to solve a puzzle anymore. You just use math to
and
solve
additionally, we're not saying that proof of stake, this new consensus mechanism, which is how people ensure the correctness of the blockchain, is like bulletproof, right? Like just like all the code, you never know there's a bug until there's a bug, right? So one could argue that proof of work, which is what Bitcoin uses, has worked for the past 10 years. So just in terms of how long it has stayed alive, it's pretty secure. And proof of stake is relatively new. So we don't really know, even though all the math checks out and statistically it's more safe. But it could always happen that one day we wake up and it says Ethereum got hacked, right? It could happen.
So that whole process happens every 10 minutes?
This is even less.
So Ethereum, the consensus, the block time is 40 seconds. Wait, 10 seconds.
It was like
12 seconds.
yeah.
It's like it's like on the order of like 10 seconds. Yeah.
So you just got it from 10 minutes, like 600 seconds to 10 seconds.
So that is an implicit upgrade from Bitcoin to Ethereum, right? And one could argue that because of this, it's easier to hack Ethereum because it takes less time to sort of get everyone's opinion and settle on, this is our block now. This is why some people sort of Bitcoin maxis, they think Bitcoin is more secure because just naturally how Bitcoin do things, it's sort of like, let's do things slow, let's do things right, let's do things on the safe side. Whereas Ethereum, because we want to actually run computation on it, we have to do things fast, right? So that is one of the reasons why people think Bitcoin is more secure, but it's arguable.
And validator isn't a person, it's like their computer doing this automatically, right? And what is the incentive for participating and paying the 32?
Remember when like Alice goes up to the calculator and she pays some money. So these people, like that money is distributed among these people. Remember we talked about burn, like Ethereum burning stuff and all of that. Yeah, you pay gas. So like this gas is distributed among the validators.
So it's like investing in a arcade company, arcade place. Everyone goes in to play the arcade to pay, right? And then as a shareholder, you get money out. Cool. Yes.
Okay, just rushing through this. If you want to write a program on Ethereum, you use something called Solidity. It breaks it down. Like, so the EVM can't understand like a high level language like Python or Java. Just basically, your computer can't understand Python or Java. Like, it needs to break it down into like assembly to like understand it itself. So Solidity breaks it into bytecode, and bytecode converts it, like is what Ethereum understands. So basically, program in Solidity, put your code on Ethereum, the blockchain, and then you can have a program on the blockchain.
And just, I guess, like for the CS savvy people here, like it's not because Python and Java are high level, that's why EVM can't understand it. Just because it's a whole new thing and has its own language. So you just need to talk to it with its own language, and sort of the language you used in the past doesn't really, it's not because of their high level, but it's just like a new thing. So you gotta do it the new way. And it does compile down to very low level code.
No, you guys can go through that. I just have a more general question.
Okay, yeah, I mean, we don't, so at the end, we're just gonna talk about, there are some applications, NFTs, everyone heard about it, that is built using Ethereum, or started with Ethereum, built on smart contracts. And if we have a source, we'll share in the after class that, blockchain programming stuff, you can check out this homework from SYS 700.
And yeah, basically, I mean, kind of explained this earlier, like just like giving an overview of like the applications of Ethereum or like any programmable blockchain. You can have NFTs on it. You can have DAOs, like which are called decentralized organizations. So like I have the image of like a thing called Links DAO. It's basically a group of people. Like it's basically like a WhatsApp group with like a bank account. So they have sources because they have funding resources. And like this group is trying to basically buy a golf course, and all the members on the golf course have access to that golf course once they buy it. So they basically are trying to like make golf something that's more acceptable and like more like decentralized, and not not only like for the rich people, so like everyone can play it. And DeFi is just decentralized finance, basically anything that facilitates finance over the blockchain, like MetaMask and Uniswap, which we'll come to later, I guess.
Later we'll have a session just talking about all the interesting concepts in blockchain, sort of taking these very theoretical knowledge to more applicable values, applicable levels, and like what you can do, what interesting companies you look into. Yeah, we'll share the slides later. So here's the resources. We'll take any questions. Yes.
Wait, is that DAO thing like that DAO thing you showed me?
Is this the thing I showed?
Yeah, that's the link.
Okay, this is not the.
It's not the.
Oh, no, it's not.
It's
Okay.
general category.
The DAO is extinct. Yeah,
I just wanted to understand, what do you guys view the relationship of like fiat currency to be with all of these blockchains? So do you believe that the US dollar would like cement its position as like the most popular fiat, because you'd have to convert all of these ETH back into dollar for it to be valuable?
So, okay, I'll try to answer the question, but like correct me and add additional questions, if I'm not going in the right direction. So like, first of all, I think this is all personal opinion, right? There's sort of no expert has opinions, but there's no correct answer on this because this is so uncertain. 10 years ago, no one knew this is going to happen.
Right.
I believe that sort of blockchain offers a certain kind of service. So, and this kind of service is just like going to arcade. They don't take real money. They take tokens that you can interact with these arcade machines.
Mm-hmm.
And why do you pay for arcade? Is because people are willing to pay for entertainment, right? And essentially, then you're talking about like how much do you value your entertainment? Is how much you're gonna pay for the token. Right? So this is the same thing. The value of these cryptocurrencies, and especially something like ETH, where it's like the value of ETH, it directly translates from the value of the Ethereum, sort of the ability to write smart contract and the things that these smart contracts can do, because you only need this to pay for this arcade. So the value of ETH depends on the arcade that is Ethereum. So I would consider cryptocurrencies like arcade tokens, like the value of it. And then in terms of sort of US dollar, I think US dollar, and from like the news I've seen, that there is going to be a government, like federal version of the US dollar on blockchain.
So you mean like the US dollar in a blockchain version?
Like a centralized.
So the government is going to issue like still US dollar, but it's in the digital form, and the government guarantees the trend, sort of the exchange between the digital version and the real version. Like they're equally real.
Instead of using a USD to buy Ethereum, you can just use a USD to buy USD digital.
It's just like the money in your bank account, which are essentially numbers, and the money that you have in cash. Like that would be how it would be like, versus like blockchain USD and real USD.
And that would be mandated by the Fed.
I think so. That's a very, very personal take.
Mhm.
But US, there has been like the Fed has said something along that line. They're looking into doing that. Like this is the whole concept of CBDC, right? Central bank digital currency, right? I think the form is going to be like, this is just going to be a new form of the same currency, because US dollar is like US Treasury, like or like these banknotes backed by like the United States, right? So what form they take actually is trivial. So the form of cash is actually trivial. It could be any form, as long as it's backed by US government credit. It's US dollar.
It's like how you move from like coins to like paper cash. Like now you're going to digital cash.
I mean, like before it was the gold standard, right? I mean, like the gold, we went out from the gold into actual fiat, and then going from fiat to digital, where we don't even have to print any more money.
But fiat is, I think digital is still fiat. Like digital fiat is still fiat, because you're using the government's
Structure.
Yeah.
Just before you guys like me, like there's BYO tomorrow.
Oh yeah, we have BYO tomorrow. Sorry, BYO tomorrow on Ochado at 6:30.
What is BIO?
BYO.
It's like a dinner you don't need to pay.
We're just like treat you guys for dinner, but you guys can sign up for the email link so we know you're coming.
And
So we can ask for the seats.
the 5-coin wallets.
Yeah, sure.
Yeah, we'll have some swag to give away as well.
Oh, yeah. All right, Steve, you can go now.
I already know that. I'll be coming.
Okay. See you tomorrow. Yeah, like be sure to sign up, but so that we can actually get these things.
Like
It should be on the email.
It's in the email.
Worst case, if you don't find it, just like message or just.
Well, just text me. I can send you the link.
You make it.
Yeah. Made a resolution. Definitely. We can make that.
Well, I can just call it make a resolution.
So, any more questions, sir? Yes, the other sir.
So when the merge happened, like how did it switch immediately? Like wouldn't the previous chain like be programmed to like work with proof of work? Like how did they just switch to proof of stake?
I don't know the exact detail, but here's a general idea. So we launched something called Beacon Chain, which is a proof of work chain, which is like does everything.
Proof of stake.
Proof of stake chain. New way to do things. They did that, I think, like 2 years back. They've already been running tests on like the stability, the security of proof of stake for quite a long time. And the merge is talking about, the proof of work Ethereum chain merging with the Beacon chain. So that is why it's called the merge, because there's already another chain that,
So nothing was altered, like it's all still.
it's all sort of continuous in a sense. Yeah, there are a lot of very fascinating technical details that I actually haven't dived into. And I think every part, so the thing about blockchain stuff is that we're all telling you like some level of abstraction, like especially when you hear analogies, like that means I'm saying bullshit, not fully bullshit. It's like very close to truth bullshit. But if you look very deep into, exactly how things work, I really encourage you to do your own research and truly understand from a fundamental level how everything works. Because only then you can truly understand what it is. And like, what's the sort of the utility of like, why do you need to understand what it is, right? Because I think in the next 10 years, this is going to be something relevant, and this is going to morph into other technologies that we'll see. And it's just like, it's like Web2 stuff, right? Like, do you want to be someone who just like, it's like your grandpa who just uses a computer and sometimes don't know how it works? Or do you want to be someone who actually understands how computer works, right? People can tell you, oh, this is just a thing that you like, type in your keys and it does something magically. But for me, I'd rather to know what is the magic? It's like there's my pitch.
Like, what does a block proposal do? Like, does block proposal mean that node does all the compute for, like, does all the calculations, or does it compile?
So the computation is actually pretty trivial. So the compute, like, because as I said, like in total, there's like a few terabytes of data, right? So in each block, the computation is like very trivial. But what does the block proposer do? It's like, as we said, like everyone anywhere can say that, like, let me use Ethereum computer, like to run my program right now, right? But how is this program actually run? So essentially you have this network computer listens to incoming requests. And then I, like, as a block proposer, I'm going to, based on how I want to do it, I'm just going to say, like, let me take a bunch of transactions, bunch of like requests to run programs, like put them in a certain order that I can decide arbitrarily or based on something that benefits me. I'm just going to hear, and then I'm going to run through the computations. And then I'm going to say, okay, here's the block.
Oh, okay.
Does that make sense? And so in the proof of work, it's sort of like who do it first. Obviously, you need to do this, and then you need to do the computation. You need to do the cryptographic puzzles too. And the first person to find the solution of the cryptographic puzzle is the one that produced the block that everyone accepts. But for now, it's actually randomly selected. So it's like, rather than you competing to sort of to sort these transactions and create do the computation, it's just like Ethereum network says, you now do it, and then you go, okay, cool, and then you does it all, and you let the other 127 people be like, sign off on it, we agree this is correct. You're good to go. Yeah.